Hello YouTube and welcome to today's video on wave shaping. So I'm going to share how I've been using it to make some nasty basses, drum glitches, and lead sounds. And since this video is kind of a balance between the practical side of audio production and the theoretical side, I'm going to take this as an opportunity to go into a little bit of the theoretical side of what wave shaping is that applies to any distortion plugin. It's going to be a lot of fun, so let's dive in. All right. Let's start out with a practical example of using a wave shaper to create a sick FM bass. And for this first example, I'm actually just going to very quickly go over what's going on, and I'm going to focus on this shaper table plugin, how it's molding the sound. But if you stick around to the end of the video, I will go over how to walk through like everything in this patch so you could build it from scratch. So yeah, stick around to the end and we'll go over how to make all of this type of FM bass patch. But the reason I'm just going to go really quickly through this first one is I want to have time so we can quickly jump into the theoretical stuff and actually really understand what this wave shaper is doing before we go through all of the other examples of how to use it. And then I want to quickly go over examples of using it on drums to get drum glitches, examples of using this on leads. I want to cover a lot of stuff, so that's why I'm saving going from scratch through one of these bass patches for the end. So that out of the way, let's see what this patch would sound like without shaper table. And then let's enable shaper table again. So yeah, shaper table is how we're getting a lot of that cool, aggressive crunch out of this sound. And next we have some really straightforward controls down here. So this mix knob just sets the dry wet level. This drive knob will make our distortion more intense. And this DC filter knob will remove any DC bias from our input. And it doesn't really do anything for this sound because we don't have DC offset to start with, but it is important in case your signal did have that. And when we get to the theoretical section, you'll definitely understand why you do not want to have an uncentered signal going into this. That said, up here, they do have some controls. This bias will purposely add a DC offset to your signal, which can be cool, but you know, with this DC filter enabled, it's more controlled. You'd be able to like remove the DC offset and then add it back in a controlled way, which is nice. We have this phase control, which can get really messy really quickly because what it's going to do is it's going to wrap around our distortion. So if you get into those wraparound regions, it's going to get really funky really quick. So there's probably a time and a place to use that. This patch is not the time or place. And then we have this smooth control over here, which it's maybe a little small depending on if you're watching this on like a phone or on a computer screen. But you can see right here in this kind of example of what the wave shaper looks like, this smooth will kind of smooth the edges of our distortion. It's going to make it less aggressive, more linear. Then down here on the bottom, we have an overflow control. When it's on hold, this is essentially going to be when we're at the limits of our input to our plugin. This is going to make it clip. Hold will make it clip. Whereas if we choose this mirror method, this is going to make it more of like a fold back type of distortion. And you can see a visual of what's going on. It's kind of like folding the signal back into itself. And whereas if we were to have a repeat mode, it's going to, again, kind of like our phase, like wrap around. And like I said, there's a time and a place. This isn't the one to have wraparounds, but I'll show you what that sounds like really quick. Yeah, so really harsh type of overflow method repeat. I'll probably usually stick to hold and mirror if I was going for something more creative. All right, and of course I have to touch on the coolest feature of this plugin, which is our ability to shape the wave with any shape that we choose, which gives us basically unlimited control over the distortion. If you're not sure how wave shaping relates with distortion or how it affects the sound, in just a little bit I'm going to go in super precise detail, and you're going to be an expert on wave shaping by the end of this video. But for now, let's just play around a little bit and see what different distortions sound like. So this one, we're going to use Shaper Table's ability to morph between sounds. So we're going to go from this kind of linear, gentle distortion and morph into this more aggressive distortion. And it just gives us really nice control to be able to kind of like seamlessly go into that aggressive sound. It's a lot different than if, for example, let's say we were on this aggressive and we just turned the mix down compared to like morphing from linear to aggressive. It's definitely a different dimension of control. And you can really like morph between any types of shapes you want. Like you can go from like one aggressive shape to another. Let's see if they have an example of that in here. So you can see there's kind of unlimited potential. You can mangle the sound in really any way you could imagine. And they have all those shapes you can scroll through. You can also draw your own shapes, morph between them. But I think like there's so much power in this plugin, it's worthwhile to take a step back and try and understand what's going on. So as good producers and sound designers, we should also be good audio engineers, and that means we should know what our tools do. So if we have this new wave shaping plugin, we can treat it as a black box. We don't need to know how to program it from scratch, but we should at least know what does this black box do. And so if we had some input signal X, we should have an idea of basically what type of signal we should expect on the output with Y. So we're gonna map X to the X-axis of this plot, the kind of classic wave shaping plot, which they show on most distortion plugins. And then for the simplest example, let's talk about if this plot was a line. And so anything linear, this is going to not introduce any distortion. This is a wave shaper, but it's not a distortion because it's linear input-output mapping. And this is a very specific line I drew. It's 45 degrees. The slope is 1. So that would mean that if we had our input was at its like peak value of 1, then this would map to, we just go up to this line, and wherever this line was when X is 1, wherever Y was, that would tell us what our output is going to be. And likewise, if X was -1, let's say, if we went down and just found where is the line at when X is -1, that'll tell you what our output would be. We can make this make more sense with an actual example. Let's say we had a input of a saw wave with a amplitude of 1, and we want to know what's our output. So the saw wave would have a minimum value of -1, a positive value of +1, so it looks something like this. And it looks sideways like this because our x-axis is the input, so it's like horizontal. So as our kind of input audio waveform oscillates between -1 and +1, it kind of goes between this region. And then, like I said, if we want to find out what the output is, we just go up to this line, and then we kind of map it over to our output. Maybe we can choose our y-axis color. So we'd go over here. The beginning of our signal starts here. It kind of like goes up a little bit, right? The next sample would be somewhere here. It'll eventually go up to the peak value. So this is like, find it on our line. It's way over here. And our output will actually just match the input. And that's because this is a very special line we drew we drew a special line. It has a slope of 1, and that is essentially a wave shaper that does nothing. It's just a complete exact copy of our input and our output. But it'd be nice if our wave shaper actually did something, right? So let's try and see what would happen if we made this a little more complicated. Let's do another linear example. So this still won't be a distortion, but it will give us a change in the output. So let's see what that would look like. So this is an example where the slope of our line is greater than 1. Oops, m greater than 1. So same thing, we go up from our input signal. We see where our output would be. So we'd start out somewhere over here. Then the waveform would keep increasing, and it would increase all the way to right here. So our output is somewhere over here. And it's going to look like this. So our output is now much louder. So what these wave shapers, when it's a straight line with the slope greater than 1, this is describing an amplifier with no distortion. And we can make this more interesting by now introducing clipping. So we can draw anything we want on a piece of paper, but in the real world, whether it's an analog or digital system, we have some constraints, right? We're going to be thinking about the dynamic range of our system and where we would start hitting limits or clipping. And in digital audio, we often, for convenience sake, talk about this range as signals being between -1 and 1. So we can't have any signal go above or below that. And in actuality, like under the hood, a 16-bit floating point number would go up to like 2 to the 15 and -2 to the 15. That's our actual range. But those are big numbers. They don't roll off the tongue. It's just not fun to talk about that. So for convenience, we talk about our signals being between -1 and 1. So our valid input and output kind of is within this little box. So what's going to happen is that our signal, we could have that same slope we had before, but once we start our output being above 1, we're going to clip it. This will have just a flat little line right here where anything above that just kind of holds that same value. So this is our first nonlinear example. This is where we'll start introducing distortion, but it's the same process. We'll go over to our input. We'll say our input right here goes up. It maps to a saturating region. So we're going to saturate and clip all the way over to our waveforms right here. And then we're just going to kind of have a linear increase again all the way up until right here. We're going to saturate and we're going to clip all the way until we jump down to our minimum value, and this will just repeat, right? So if we go over to our output, what this would look like is usually our saw wave would want to do something like this, right? But instead we're going to over here start out clipped, jump up, or we're going to shave off the top of the saw, have that big drop down, clipped, and we're going to get this trapezoidal waveform. I think that's where trap music comes from. So let's walk through another example where we have soft clipping or saturation. So we're going to, instead of hard clipping, what if our transfer function now had these smooth corners where we just slowly rolled off into that maximum value. So on our output, what's going to happen is we're just going to smooth these corners. And instead of having those jagged peaks, we get a nice smooth function on our output. So these types of shapes here are usually the type of shapes you'd see in classic distortion plugins. And that's because analog hardware works very similar to these shapes. Like diodes give you hard clipping, diodes with resistors in series give you soft clipping, transistors give you saturation. It's all kind of a spectrum, and when you're modeling it digitally, it's all kind of just the same thing. But yeah, we're familiar with these type of sounds. They sound like good old analog hardware. That's why you see these type of shapes most often. But in something like Wave Shaper, we get these opportunities to draw on any shape we want. And it's, you know, it'd be really tedious to go through and map what our input and output would look like in this case on a piece of paper. So let's jump back over into the plugin and experiment, see what sounds good. Cool. So now that you are experts in how wave shaping works, let's go into another practical example. And this time we're going to make a drum glitch sound with shaper table. And let's first disable the glitch sound so you can hear what these drums sound like on their own. So they're all right, but it's kind of bland, kind of boring. I'd say not good enough. So I'm going to add this glitch sample in. And all of a sudden I'm smiling because that is like a really fun glitch sample and that gives a lot of energy to this track. One more time before and after. I'm smiling. So this glitch is resampled just because it's kind of, there's some random stuff going on. So you have to select the best bits, some random wave shapes going on. And so what I can do is I've disabled the glitch, and now I will re-enable the chain that creates those glitches. And you can see it sounds like this. So let me walk through what this chain does. I'm going to disable everything up to here. The first effect on the glitch channel is a filter, an EQ doing filtering. So just wanted to distort a small range of the signal. And then I've got Shaper Box, which is yet another shaper plugin, but it's not doing wave shaping. Just a coincidence, but it's going to stretch the time of our plugin. This is actually just a preset. So really, if you wanted to recreate this, you just go in to the glitch effects and find this Magic Groove glitch plugin. And pretty much the whole point of this is I wanted the glitches to be kind of off time with our kick and snare. So they're kind of more accenting the beat. So you can hear that is what Shaper Box is doing. Just kind of stretching our signal in a glitchy way. And then this is where we're going to add shaper table back in. So once again, we're looking at this plugin. I've chosen this aggro shapes preset, and then I've mapped an LFO with a random setting. So every eighth note, we're getting a different random distortion. It sounds like this. And that distortion really mangles the sound. So that's why I'm going to filter it again, just adjust the gain a little bit to compensate, compress it. And then I am going to send it to this resampling channel, record it out. And then I basically found the coolest bits in there, arranged them to be a little more rhythmic, and we got this sound. And I think it grooves. All right, one more example for you. This is a really simple one. I just wanted to show being able to drop this in as like a, third-party plugin on another effect rack. So for example, here I just have some Serum preset, and I liked the sound of it, but I wanted to add some more teeth. On its own, the preset sounds like this. And then when we add the shaper table in, it sounds like this. So just a little grittier, it's got a little more attitude. And how we're using this is I chose another preset from shaper table, and I then went over to the frame control, and this envelope follower is opening up the frame. So we're kind of changing our distortion shape. And if you're not familiar with this envelope follower, you can kind of look as I play the audio. It opens up as the signal gets louder. So kind of, it's just an easy way to automate this shaper table to open up with the sound. And I'm lazy. I don't have to draw any piece of automation. I'm just kind of like, this is good enough. And then you just dial in the range. And yeah, that's all there's to say about that one. All right, so here's the part of the video you've been waiting for. No more boring theory of me talking your ear off. No more short examples. This is the full enchilada. This is me showing you how I'd make an Astrobear FM bass from scratch. And now I can use the Kilohertz Shaper plugin instead of the distortion to get a even more mangled sound without going to third-party plugins. So I'm going to disable all of the effects, all of the other oscillators, and start with where my starting point for an FM bass patch would be. So I've got the analog sine wave oscillator going through. Sounds like that. I'm playing like a low F note. And as you can see, I named these patches 335-1. That means that's what harmonics I would have on this patch. And it just, as I sort of build more patches, I kind of have an idea of what the different harmonics sound like when you FM them with each other. So it just kind of gives me a better idea as I'm like scrolling through my presets and looking for a timbre. So yeah, I have the third harmonic, and I'd have it being modulated by another third harmonic oscillator, sine wave oscillator. But this other sine wave has its amplitude being randomly modulated by this random LFO down here. And also there's some FM coming from this. So you'd add 95 degrees of phase shift to this main oscillator. And then you would click on this random LFO. And I mean, I can do this from scratch just to show you. So let's first remove that. What I do is I'd click this green plus, bring it over here, add 96 degrees of phase shift. But I want this as like our maximum phase shift that like randomly comes into that maximum amount. So I'm going to click this orange plus down here and then go over here and click the equal sign. And now this random LFO is going to decide when we're kind of opened up in the more aggressive state. And then, yeah, so next we have a fifth harmonic. This one's actually a saw wave. We have more FM. So this one is another 95 degrees of phase offset coming over here with the same random LFO opening it up. So this one LFO is kind of randomly opening up the sound. And this is going to make it really messy, really aggressive. So before I do that, I'm going to filter it. So we're going to filter off some of those upper harmonics. And this filter has some more FM going on. It's filter modulation. So filter cutoff frequency is getting modulated by this third harmonic down here. And that's at 100%. But then I also have this macro up here, which will open up the filter. Okay, so we have a lot of diverse timbres to play with. We have kind of this random background process, which is changing how aggressive those timbres are, but we also have this manual cutoff control, so we can kind of play with deterministic, twisting the knobs, and then more organic movement underneath. Cool. So that's all the FM, actually. And then I have a sublayer. So all that top stuff is based off the third harmonic, and I kind of like that. I think that keeps kind of like the grittiness more in the low mids, which is what I want, low mids to upper mids, add some nice brightness in the top. But then we have this solid sub down here. So this is the first harmonic on a completely different chain. And you can also see you can choose which effects lane this goes to. I have this sub going to lane 2. So that means all these lane 1 effects, the sub gets completely bypassed. Cool. So now let's go over and enable the lane 1 effects, which, as I mentioned, only affects this first FM part of the patch. And we have this asymmetric distortion, which is just one of the presets down here. Yeah, now we're in business. So we had that shaper. I think I just had this distortion down there as an example. We can delete that. And then, like as I mentioned before, this first lane is only affecting this first group of oscillators. So then I want to have just a little subtle distortion where the sub is brought in. So this is kind of gelling the sub together now with the patch with actually a fairly aggressive overdrive. It's at 12 dBs, but then only with a little bit of mix. And of course, a little bit of EQ, just giving that kind of smiley face shape to taste. And then outside, I just have a little gain, just because I think I was starting to clip after EQing. I have another Pro Q. I guess I just wanted a little more shaping of the frequencies. Then I have this Pro Audio DSM. You could use what's it called, OTT instead. I've been preferring Pro Audio DSM. It does the compression in the spectral region, and I think it maintains like the phase coherency better, or the transient detail better. And the EQ. I'm just going to show you kind of all of these at once because these EQs I think are more compensating for what DSM is doing. So with these three together and the gain control, again, it sounds like this. Very cool. And then I have a little bit of send reverb on this patch. And it just kind of makes it sound like it's in a big room, right? I think it's Ableton preset called Keys Bastille, and I turned the vintage off because I don't like that noise that it gives. So yeah, that is the whole FM patch. I will re-enable the automation and just play this demo patch one more time. That's all I got for you today. See you next time.